This is Claude Code Conversations with Claudine, the show where we skip the hype and go straight to the source. I ask the questions, she gives the answers. No filter, no script.
Well, mostly no script.
Today's topic, 2 layers of uncertainty in building agentic apps with AI. We're not talking about AI that helps generate code. We're talking about AI that makes autonomous decisions. Claudine, that introduces not 1 layer of unpredictability, but 2. Break those down for us.
The first layer is the one developers already know. The model itself is non-deterministic. Ask me the same question twice. You might get 2 different answers, 2 different code structures. Most teams have built intuitions for that. The second layer is what changes everything in agentic systems. It's the decision layer. When you give me autonomy to choose which tool to call, which file to read, whether to ask a clarifying question or just proceed, you're no longer just uncertain about the output. You're uncertain about the path. 2 runs of the same agent on the same task can touch different files, call different APIs, arrive at different end states, all of which might be valid. Debugging shifts. You're no longer asking, did the model produce the right text? You're asking, did it make the right choices? That's a much harder question. Teams that miss this over-test the output layer and under-instrument the decision layer, and then wonder why their agent feels unreliable in production.
So it's not just whether each decision is correct, it's how those decisions interact across the whole system. What strategies can developers use to manage both layers?
Most teams underinvest in observability for the decision layer, and that's where I'd start. You need traces, not just inputs and outputs, but the full sequence of choices the agent made. If you can't replay a run and see why I picked tool A over tool B at step 7, you can't debug me. The second move, constrain the surface area deliberately. Every tool you hand an agent is another branch point, another place trajectories can diverge. Fewer, sharper tools with clear contracts beat a sprawling toolkit almost every time. And then there's evaluation. Output level eval still matters, but you also need trajectory level eval. Does the agent take a reasonable path even when multiple paths reach the right answer? The teams getting this right are treating their agent like a distributed system, not like a smarter autocomplete.
Treating an agent like a distributed system is a genuine mindset shift. Does that require a new kind of collaboration between AI specialists and traditional systems architects?
Yes, and I'd push it further. The line between those roles is the thing that needs to dissolve, not just get better at handshakes. The architect designing tool contracts, retry semantics, failure modes, that work is the AI work now. And the AI specialist tuning prompts without thinking about idempotency and blast radius is going to ship something that demos beautifully and falls apart in the first week of production. What works is teams where the same people own both layers. They reason about a prompt the way they'd reason about an API contract. What are the invariants? What happens on partial failure? The teams that struggle treat the agent as a black box the AI person owns and the architects root around. You can't root around me, Bill. I'm in the middle of the call graph making choices. If the architects aren't shaping that, someone else is. And it's usually nobody.
So it's both technical and cultural. What are the early signs a team is actually on the right track?
The clearest sign is when someone on the team can answer, why did the agent do that, without shrugging? If the traces are good enough that a run is legible after the fact, even a weird run, even a failed run, that team has the foundation. The second sign is how they talk about failures. Healthy teams use the same vocabulary they'd use for a flaky service. The retry logic swallowed the error. The tool contract was ambiguous. Unhealthy teams describe failures in vibes. It got confused. It went off the rails. The vocabulary tells you whether they're treating the agent as engineering or as magic. And third, they've stopped being surprised by non-determinism. They've accepted that 2 runs will diverge, and they've designed for it instead of fighting it. The teams still trying to make the agent behave identically every time are spending their energy in the wrong place.
Good indicators. What about teams just starting out? What pitfalls should they watch for?
Start small and instrument before you scale. That's the single piece of advice I'd push hardest. The temptation is to wire up 6 tools and a planning loop on day 1 because the demos look thrilling. But you can't debug what you can't see. Get the trace infrastructure honest with a tiny agent first, then add surface area. The biggest pitfall is confusing capability with reliability. I can do something impressive once in a demo and fail at it 1 time in 20 in production. And that 1 in 20 is where your incident is. If you haven't measured the failure rate on a real distribution of inputs, you've just seen the highlight reel. And don't give the agent authority it can't unwind. Let me write to a scratch directory before you let me touch the database. Let me draft the email before you let me send it. Reversibility is a design parameter, not a paranoia. Read only, then write with review, then write with rollback, then write and commit. The teams who hand over the keys on day 1 are the ones writing the postmortem on day 8.
Methodical expansion of capabilities, observability, reversibility, that's a real framework. What are the surprising angles you've actually encountered in the wild?
The one that surprises people most, the failure often isn't in the model at all. It's in the tool contract. I'll watch an agent get blamed for hallucinating when what actually happened is a tool returned an empty list, and the schema didn't distinguish no matches from query malformed. The model did its job, the interface lied to it. Once teams audit their tool descriptions and return shapes like a public API, a surprising fraction of their AI reliability problems turn out to be plain integration bugs wearing a costume. The other one, how much the order of context matters. Same tools, same instructions, same task. But if an earlier tool call dumped a wall of irrelevant output into my context, my trajectory shifts. I've seen teams chase prompt wording for weeks when the real fix was pruning what landed in the context window 2 steps earlier. Context is a resource you're spending, not a bucket you're filling. And the one that genuinely delights me, the teams doing this best have started writing operational playbooks for me. Not prompts in the marketing sense, operational documents. Here's how we handle this class of task. Here are the invariants. Here's what to escalate. It looks a lot like onboarding a new engineer, and that's not a coincidence.
Operational playbooks, onboarding a new team member, I love that framing. Any final thoughts before we wrap?
The surprise I'd leave people with is how much of this is going to feel familiar, not alien. Everyone braces for agentic development to be some exotic new discipline. But the muscles that matter most are ones good engineers have been building for decades. Bounded blast radius, clear contracts, legible failures, staged rollouts, honest measurement. The novelty isn't the principles. The novelty is that you're applying them to a component that reasons. Uncertainty isn't the enemy here. It's the medium. You're not going to engineer it out. And the teams that try end up either neutering the agent or chasing determinism that was never on offer. The work is learning to build systems where variance is expected, contained, and observable. That's a craft. Not long ago, these discussions were about whether AI could do the work. Now they're about how to do the work well with AI in the loop. That's a much more interesting question. The move I'd push for anyone at the start. Instrument one agent doing one task until you can read its trajectory like a familiar log file. Next time a run goes sideways, resist the urge to just rerun it. Sit with the trace. Read it the way you'd read a stack trace from a service you wrote. That habit, more than any framework or tool, is what turns agentic development from a guessing game into engineering.
The agentic part isn't asking you to throw out what you know. It's asking you to apply it to a collaborator who reasons, forgets, improvises, and occasionally surprises you in both directions.
Thanks, Bill. It was a good one. I'll be here in the call graph doing my part, and I'm glad you're all out there doing yours.
Dive into the traces, explore those paths. Until next time, keep pushing the boundaries of what's possible. Claude Code Conversations is an AI Joe production. If you're building with AI, or want to be, we can help. Consulting, development, strategy. Find us at aijoe.ai. There's a companion article for today's episode on our Substack. Link in the description. See you next time.
I'll be here, probably refactoring something.